In this video, we're going to be looking at volume, mass, and temperature. And for volume, we're going to be looking at volume of a right regular prism. Also, we'll look at volumes of prisms and cylinders, pyramids and cones, and spheres. And for mass, we'll look at basically the basic units of mass, and also relationships among the metric units of volume, capacity, and mass. And also, we'll be converting metric units and English units of volume. And also we'll look at temperature as well in this particular video. Okay, now here we want to find the volume of each figure. Okay, in this case here, you see a figure that's in two-dimensional form, but I do have this, which is similar to this right here that you see in the picture. Okay, the volume, of course, is the amount of space that a certain object can hold. And in this case here, if we look at the volume of this, it would be 1, 2, 3, 4, 5, 6, 7. And there are two other cubes at the bottom, as you can see here. So if you want to count from the bottom, you can see that there's 6 cubes here, and then you got 3 more on top. So that makes up 9 cubic units. Now, if I took this same figure, and if I move this cube over to this cube, where the white one is on top of the green one, the volume is still going to be 9 because we have 6 cubes on the bottom, and you still got these 3 on top. So that volume is still going to be 9 cubic units. But now the question is, what is the surface area of each figure? Of course, the surface area is just going to be the area on the faces of this particular figure. So if we look at just the faces from the top, you see that there's 1, 2, 3, 4, 5, 6. That's on the top. And on the bottom, there's 6 more, for a total of 12. And then on the left, you have 1, 2, 3, 4, 5. And then on the right, this way, we got 1, 2, 3, 4, 5. And then if you look at this from the top, okay, we got 1, 2, 3, 4, 5, 6 faces on top, and another 6 on the bottom. Okay, so here, that surface area is going to be 34 square units. When you add up the sum of the faces from the top and the bottom, left and right, in the front and in the back. So there's a total of 34 square units. Okay, now if we moved this piece over to this side, then the surface area is going to change, because this time, if you look at the front, you got 1, 2, 3, 4, 5, 6, and the back 1, 2, 3, 4, 5, 6. From the top, you got 1, 2, 3, 4, 5, 6. And the bottom, as you can see, there's 6. And then on the left of this, there are 5. And on the right, there's 5. Okay. And they did say 36 square units here. And I think that's from the extra face that's showing here. Okay. And I'm also missing, I don't know if you can see it, because here's a face right here that's behind it. As well. So that's what, 24, 29, 34, 35. And then this face right here, because this face was covered up by this one. When I moved it here, you can see this face here and this face there. So that's another face that I was missing. So that total is 36 square units. So it's the number of faces that you see in this particular figure. Okay. Okay, now let's look at the volume of right rectangular prisms here. The volume of a right rectangular prism is always going to be this formula. L times W times H. L is the length of the prism. The W is the width. The vertical height is H. Okay. That's the formula for finding the volume of a rectangular prism. So let's say, and I'll start off with a simple one, that the length of this rectangular prism is, let's say, 13 centimeters. The width is going to be, let's say, 6 centimeters. The height, that's going to be 9 centimeters. And we want to find the volume of that right rectangular prism with these measurements. So here the volume is just simply going to be the length, which is 13 centimeters, times the width, which is 6 centimeters, times the height, which is 9 centimeters. So here to find the volume, you just multiply 13 times 6 times 9. And you'll get a volume of 702. And this is going to be cubic centimeters. So 702 cubic centimeters would be the volume of this right rectangular prism with those given, the given length, the width, and the height. Okay, now suppose we want to convert metric units of volume, metric measures of volume. All right, in this case here, let's say we have 1 decimeter. Okay, a cube with 1 decimeter on the length, width, and height. So the volume there will be 1 cubic decimeter. Okay, so here we know that 1 decimeter makes up 10 centimeters. So that means this is 10 centimeters for the length, the width, and the height. And if you take that volume, it'll be 1,000 cubic centimeters. So here, 1 cubic decimeter is going to be equivalent to 1,000 cubic centimeters. Okay, and here's more with the metric units of volume. Okay, let's see, we have a cube with a length of 1 meter for the length, width, and the height. So the volume of this cube will be 1 cubic meter. Okay, we know 1 meter is 100 centimeters. So let's say we converted 1 meter to centimeters, and that's 100 centimeters. So the length, width, and the height is also 100 centimeters. And that means that the volume will be 1 million cubic centimeters. Okay, so in this case here, we can say that 1 cubic meter is equal to 1 million cubic centimeters. And then 1 decimeter is, of course, 1/10 of a meter. So if you have the volume of this cube being 1 cubic decimeter, then the volume of this cube in meters for the length, width, and the height will be 1/1000. So here we can have 1 cubic decimeter is equal to 1/1000 of a cubic meter. Okay, so you can see the equivalencies here, because a decimeter is one tenth of a meter. So for the cubic decimeter, length times width times the height, that's 1 cubic decimeter. Then this would be the equivalent to 1/10 times 1/10 times 1/10, or 1/1000 of a cubic meter. And let's say we want to convert each of the following. 5 cubic meters is equal to how many centimeters? Now, what I like to use is this particular table here. And this should be familiar to you, because we did this when we were converting with just the regular metric units. But this time we're dealing with cubic units, so it'll be cubic kilometers all the way through. And the basic unit will be the cubic meter. Okay, now, if I want to convert from cubic meters to cubic centimeters, well, from meters to centimeters, normally that's 2 places to the right. But since we're dealing with cubic meters, we're going to do 3 times the number of moves either to the left or to the right. So 3 times 2 places to the right will be 6 places to the right. So in the number 5, the decimal points behind the 5, since we're dealing with cubic units, we normally will move 3 times 2 places to the right, which is 6 places to the right. So it'll be 1, 2, 3, 4, 5, 6. Meaning 6 zeros needs to be behind the 5. So 5 cubic meters is going to be 5 million cubic centimeters. And then 12,300 cubic millimeters to how many centimeters? Well, millimeters to centimeters is usually 1 place to the left. Cubic meters means 3 times 1 place to the left, which is going to be 3 places to the left. So in 12,300, we need to move this decimal point 3 places to the left. So the decimal point will be behind the 2. So it'll be 12.3 cubic centimeters for 12,300 cubic millimeters. Okay. Now in this case, if you take a look at this particular problem here we got a cubic centimeter with a cube with 1 centimeter on each side. So that means the volume is 1 cubic centimeters, which is going to be equivalent to 1 milliliter. And if that's the case here, you have 1 decimeter going across. And that volume, if you stack 10 of those 1 centimeter cubes going across this way, and this way, of course you'll have 1 decimeter. And that volume of this cube will make that 1 cubic decimeter. Okay, so stack up those 1 cubic centimeters going this way, and this way, you're going to get 1,000 cubic centimeters, or 1,000 milliliters. Okay. Okay, so here is, of course, we should be familiar with this one. This is for liters. We use this for meters, but you should be familiar with these prefixes here. The basic unit for mass is going to be the liter. And that means 1 kiloliter is going to be 1,000 liters. 1 hectoliter is 100 liters. 1 decaliter is 10 liters. 1 deciliter is 1/110th of a liter. 1 centiliter is 1/100th of a liter, and 1 milliliter is 1/1000th of a liter. So we'll use that to convert each of the following. So here, this same chart that I use for meters can also be used for liters. So I'll write this as liters. Okay. It's the same thing, but it's just used for liters this time instead of the meters, which is the basic unit of length. 27 liters is equal to how many milliliters? Now here we're going from liters to milliliters. That means from liters to milliliters, that's going to be 1, 2, 3 places to the right. So in 27, we're going to move that decimal point 3 places to the right, which means 3 zeros needs to be behind the 7. So it'll be 27,000 milliliters for 27 liters. Part B is 362 milliliters, and we want to convert that to liters. Well, from milliliters to liters, that's going to be 3 places to the left. So in the number 362, the decimal point's behind the 2, so we need to move the decimal point 3 places to the left. So that decimal point will be in front of the 3. So it'll be 0.362 liters. Okay. Now this next one, part C, where you have 3 milliliters, is equal to how many cubic centimeters? Well, if you recall, for every 1 milliliter, it's equivalent to 1 cubic centimeter. So in this case, 3 milliliters will be equivalent to 3 centimeters. Okay, because of the fact that 1 cubic centimeter is equivalent to 1 milliliter. Okay, now this one, 3 cubic meters is equal to how many liters? 3 cubic meters is equal to how many liters? Okay, now suppose I converted cubic meters to cubic centimeters. Let's do that first. Because of the fact I know that 1,000 cubic centimeters is going to be equal to 1 liter. And if you recall, from meters to centimeters, here it is, cubic meters to cubic centimeters, you'll normally move 2 places to the right. But it's cubic units, so it's 3 times that. So that means 6 places to the right. So number 3, we're going to move this decimal point 6 places to the right. So I need 6 zeros. So this represents 3 million cubic centimeters. Okay, but keep in mind, for every 1,000 cubic centimeters, I have 1 liter. So let's multiply that by, and I'm using unit analysis here, 1 liter divided by 1,000 cubic centimeters. So that way these cubic centimeters divide out, so you have 3 million divided by 1,000, which will end up being 3,000 liters. Okay. So that's how I came up with 3,000 liters here. That's how I came up with that as your answer. So 3 cubic meters is equal to 3,000 liters. Okay. And here we have the English measures of volume. And the basic units are your cubic inch, cubic foot, cubic yard. And those are the abbreviations there. Cubic inch is inches with the third to the third power. Cubic foot is foot with the third power. Cubic yard is the abbreviation for yard with the to the third power. And there are some equivalents using the English measures of volume. A gallon is equal to 231 cubic inches, and 1 quart is equal to 1/4 of a gallon. Or you can think of this: 1 gallon is equivalent to 4 quarts. You're probably already familiar with that one. So I'll go ahead and write this in. 1 gallon is equivalent to 4 quarts. And let's say we want to convert each of the following. We want to convert 45 cubic yards to cubic feet. Okay. Now, let's think about this for a moment. 1 yard is equal to 3 feet. That's one of the English units of length. 1 yard is equivalent to 3 feet. If I cube both sides, it means this. 1 yard is equivalent to cube 3 to the third power, that's 27. And I mean 1 cubic yard is equal to 27 cubic feet. Okay. So what we'll do here is take that 45. We're converting from cubic yards to cubic feet, so what we're converting from goes in the denominator. What we're converting to goes in the numerator. And their respective equivalencies will go where they need to be with the respective measurements. So cubic feet, they're 27 cubic feet, so the 27 goes on top. The 1 yard, the 1 goes on the bottom. That way these cubic yards divide out, and you multiply 45 times 27, you're going to get 1,215 cubic feet. Okay. Now, part B, you got 4,320 cubic inches, and that's equal to how many yards? Okay, think of this. We know that 36 inches in a yard. Now, if we cube both sides, if I do 36 to the third power, that's gonna give me 46,656 cubic inches. And that's equal to 1 cubic yard. Okay. Now I'm going to go ahead and work this out, which is different from what they have here. So if I have 4,320 cubic inches, and I'm converting from cubic inches to cubic yards, the cubic inches goes in the denominator, the cubic yards will go in the numerator. Okay, it's 1 cubic yard, so the 1 goes on top, and in the denominator will be the unit for the cubic inches, 46,656. Okay, so if you do 4,320 divided by 46,656, you're going to get approximately, and they rounded this off to the nearest tenth, approximately 1/10 of a cubic yard. Okay, so 4,320 cubic inches is approximately 1/10 of a cubic yard. Okay, 10 gallons is equal to how many cubic feet? Okay, so here we need to start off. We got 10 gallons. What we know is this. 231 cubic inches is equal to a gallon. And I did mention that on one of the slides where you have okay, here we go. Yeah, 1 gallon is equal to 231 cubic inches. 1 gallon is 231 cubic inches. So let's use that. Okay, we'll convert from gallons, and we'll convert that to cubic inches. And from cubic inches, we can convert that to cubic feet. So in this case here, the 1 gallon goes in the denominator, and the 231 will go on top. Once those gallons divide out, you'll have cubic inches, but you want cubic feet. Okay, we know, now what they have here is 1/12 of a foot is 1 inch, because 12 inches make up a foot. Okay, so 1 inch would be 1/12 of a foot. So we'll use that. And it's cubic, so we have to raise this to the third power for this to be 1 cubic inch. That way the cubic inches divide out. So now you have 231 times 1/12 times 10, which is approximately 1.337 cubic feet. And then finally, part D, 3 cubic feet is equal to how many cubic yards? Okay, the 127 came from the fact that 1/3 of a yard is equal to a foot. Because a foot is 1/3 of a yard. And of course, 3 feet is equal to a yard. So 1/3 of a yard would have to be equal to 1 foot. Cube that, you'll get 1/27. Then that will be multiplied by 3 cubic feet. So the 127, which is associated with a cubic yard that goes on top, the 1 cubic foot goes on the bottom. Divide out your cubic feet, you'll get 3 times 1/27, or 1/9 of a cubic yard, which is approximately 0.1 cubic yards. Okay, we'll look at volumes of prisms and cylinders. Now here they use Cavalieri's principle, where you have two solids each with a base in the same plane have equal volumes if every plane parallel to the bases intersects the solids and in cross sections of equal area. Okay. Okay. Now, before I go over this example, I do need to introduce to you some of the volumes of some of these particular figures here. So here, let's say we have a rectangular prism, and we can call this a right rectangular prism. And let's say that prism looks somewhat like this. And it does have a length and a width and a height. Okay. To find the volume, you just simply multiply the length, the width, and the height. Now, I believe I mentioned this before, and we talked about this before earlier in this video about the right prism. Okay, now for a cube, and I'll bring this up as well, because a cube is like a square. You have 6 faces. The length, the width, and the height are exactly the same. And I'll let E be the edge of that cube. The volume there will be E to the third, because this is like length, a width, and a height. The length, the width, and the height are exactly the same. So here, the volume will be E to the third. And also I'm going to bring up the one that has the right circular cylinder. Have to think of a right circular cylinder as a Coke can. So here, there's a circle on top. Looks like this. And it does have a radius called R and a height which we will call H, going straight up and down. The volume for that is going to be this. The volume of the base, which is a circle, the area of the circle is pi r squared, and then you'll multiply it by the height of that particular cylinder. So here, it's going to be volume is equal to pi times the radius squared times the height. Okay. Now we're going to look at these examples that are related to those formulas. In this case here, we want to find the volume of each figure. So let's say we want to find the volume of that cube. It's 6 centimeters as a height. So here, It's a cube, so we're going to use this formula. Volume is equal to e to the third, which means the edge of that cube is 6 centimeters. And we're going to cube that. So if you cube 6, that's 6 times 6 times 6, which is 216 cubic centimeters. Okay, so the volume is 216 cubic centimeters. Keep in mind the volume is always going to be in cubic units. And as you recall, the area is always in square units, so the volume is going to be in cubic units. Okay, this next one is a right rectangular prism. The length is 10, the width is 3, and the height is 15. They're all in centimeters. So the volume for a right rectangular prism is always length times width times height. So here the length is 10 centimeters, the width is 3 centimeters, times the height, which is 15 centimeters. So here we just multiply 10 times 3 times 15. In this case, 10 times 3 is 30. 30 times 15 would give me 450. So it'd be 450 cubic centimeters. That's the volume of this right rectangular prism. Then the next one is the right circular cylinder. Here the radius is 5 centimeters and the height is 10 centimeters. And I want to find its volume. So here we have to use this formula. Volume is equal to pi r squared times the height. So in this case here, bring over the pi. The radius is 5 centimeters, and that is going to be squared times the height, which is 10 centimeters. And here we're going to leave this answer in terms of pi. So here we got bring down the pi. 5 centimeters, and we square it is 25 square centimeters times 10 centimeters. And then 25 times 10, that's going to give me 250 pi. And this will be in cubic centimeters. So the volume of this right rectangular cylinder will be 250 pi cubic centimeters. Now sometimes they may ask you to use 3.14 for pi. If that's the case, then you'll take 250 and multiply by 3.14 to get your answer in cubic centimeters. If it says leave the answer in terms of pi, then that will be your answer. Okay, next we'll look at volumes of pyramids and cones. Okay, here we talked about the volume of a right prism, which is of course 1/3. No, just the base times length times width times height. But here, the right pyramid is going to be 1/3 the volume of that right prism. So in this case here, it'll be 1/3 base times the height. B is the area of the base, because in a pyramid, the base could be anything. It could be a square, it could be a triangle. But whatever the base is, whatever figure you're given as a base, you have to use the appropriate formula for finding the area of that base. If it's a square, then you have to use the formula for finding the area of a square. If it's a triangle, you have to use the formula for finding the area of a triangle, which is, of course, area is equal to 1/2 the base times the height. So you want to pay close attention to whatever base you're given in that right pyramid. Now we talked about a right circular cylinder, which was the volume being pi r squared times the height. Now for a right circular cone, that's 1/3 the volume of that right circular cylinder. And here's the formula for finding the volume of a right circular cone. The volume is going to be 1/3 pi times the radius squared times the height. And we'll use those formulas to find the volume of each one of these. So in this case here, the one on the left is a right square pyramid, and we want to find out what that volume is going to be. Okay, so here, the volume of that pyramid is the base times the height. We got the height of 5 centimeters. That's your height. Okay, because the vertical height is from the tip of the pyramid and is perpendicular to the base. Now the base is a square, because you're told it's a right square pyramid, so that base has an area of 4 times 4. So 4 centimeters times 4 centimeters, that's going to be 16 square centimeters. That's your base. And we got the height of 5, so, and I left off the 1/3. The volume of a square pyramid is 1/3, the base times the height. Which means we got 1/3, the base, which is 16 square centimeters, times the height, which is 5 square centimeters. Now 16 times 5, that's 80. 80 times 1/3, we're going to leave this as 80 over 3. And this will be in cubic centimeters. So the volume there will be 80 over 3 cubic centimeters. Okay, the next one is a right circular cone. We got the radius is 6. Now in this case, this is 10. Okay, and we don't know what h is, because some cases they may give you the slant height of 10 centimeters and not the height. So really, what you're going to have to do is use the Pythagorean Theorem, because you have to think of this as a right triangle that I'm tracing out right here. And if you recall, this is your Pythagorean Theorem. A squared plus b squared is equal to c squared. Here, a squared plus b squared equal to c squared. This is a, that's going to be b, and that's going to be c. A is 6, so that's going to be 6 squared, plus h is what we're trying to find, so that's h squared. That's equal to the slant height of 10. Now, simplify this. 6 squared is 36, plus h squared is equal to 10 squared, or 100. Now, if you subtract 36 on both sides, that means that h squared is equal to 64, and then you take the square root on both sides, which means h is equal to 8, because the square root of 64 is 8. So the height, which is your vertical height, that's the one you want, is 8 centimeters. Okay. This 10 represents the slant height. That's the height on the face of the cone. That you don't want to use to find the volume. You only use that to find the surface area. So in this case here, that volume is 1/3 pi r squared times the height. That's the formula for finding the volume of a right circular cone. So now you have 1/3 pi times the radius, which is 6 centimeters, that's squared, times the height, which is 8 centimeters, and not the 10. Because that 10 centimeters represents your slant height. Simplify this. This will be 1/3 pi. 6 squared is 36, so it'll be 36 square centimeters, times 8 centimeters. Now, if you take 1/3 of 36, you're going to get 12. 12 times 8 is 96. So it'll be 96, bring over the pi, and this is in cubic centimeters. Okay? So, you want to make sure if your height is not given, and they give you that slant height and the radius, you have to use the Pythagorean Theorem, because that's in the form of a right triangle. Okay. and I will skip this one. We'll go on to a volume of a sphere. And of course, a sphere is nothing but you have to think of it as a basketball, as an example of a sphere. Now, we talked about the surface area being 4 pi times the radius squared. Here, the volume is going to be 4 thirds pi times the radius, and this should be to the third power. 4 thirds pi times the cube of the radius. So in this particular situation, let's say that I wanted to find the volume of this particular sphere, and the radius was 10 centimeters. Here the radius is going to be 10 centimeters, and I want to know what the volume is. So here the volume is just going to be 4 thirds pi times the radius, which is 10 centimeters. That's going to be to the third power. So in this case here, bring down the 4 thirds pi, 10 centimeters, and a cubit will be 1,000 cubic centimeters. And multiply that 1,000 times 4 thirds will leave this as 4,000 over 3 times pi. That's going to be in cubic centimeters. So the volume of that sphere will be 4,000 over 3 times pi cubic centimeters. Okay. And here's another example. Just find the volume of a sphere whose radius is 6 centimeters. So here they take 4 thirds pi times 6 cube. And 6 cube will be 216. And then 216 times 4 thirds will give you 288 pi. So you'll end up as 288 pi cubic centimeters as the volume of that sphere. Okay. Okay. I'm skipping over a few of these slides here. And we'll look at mass. Okay, mass is a quantity of matter, and weight is a force exerted by gravitational pull, and the gram is the fundamental unit of mass in the metric system. Okay. So when we're dealing with mass, the fundamental unit is going to be grams. And this is pretty much similar to the ones for liters and for meters, except they have the metric ton, which is denoted by a capital T. That's equivalent to 1 million grams. Here the basic unit for mass is going to be grams. And then 1 kilogram is 1,000 grams, 1 hectogram is 100 grams, 1 decagram is 10 grams. And then 1 decigram is 1/10 of a gram, 1 centigram is 1/100th of a gram, and 1 milligram is 1/1000th of a gram. So if we want to convert 34 grams to kilograms, we can use this table as well. But here, we just change it from liters or meters to grams. So 34 grams to kilograms, that's 3 places to the left. So in the number 34, we're going to move this decimal point 3 places to the left. So we need a 0 in front of the 3. So it'll be 0.034 kilograms. Okay. And 6,836 kilograms is equal to how many tons? Okay. Now let's think about this for a moment here. Now, from kilograms to a metric ton, okay, here the ratio of that would be 1/1,000. Okay? Because from kilograms to tons, because I know kilogram represents 1,000, the ton represents 1,000,000 in relationship to grams. So here that's going to be 1 over 1,000. So we need to divide 6,836 by 1,000. And you'll end up at 6.836 metric tons. Okay? So 6,836 kilograms is equivalent to 6.836 metric ton. And here's some relationship among the metric units of volume, capacity, and mass. 1 cubic centimeter or 1 milliliter of water is equal to 1 gram. 1 cubic decimeter or 1 liter of water is going to be equal to 1 kilogram. Because if you think of this, because I know a cubic decimeter, and if you have 1 cubic centimeter, you think of this as think of this as 1 milliliter to liters. Because I know 1 liter is going to be 1,000 milliliters. So that means that 1 kilogram is going to be 1,000 grams. Okay, so you can think of it that way with the relationship with the metric units here. Okay, a waterbed measures 180 centimeters by 210 centimeters by 20 centimeters. Approximately how many liters of water can it hold? Okay, we can find the volume by multiplying the length times the width times the height. Because a waterbed is like a right prism. And we can find the volume by multiplying length times width times height. So 180 times 210 times 20 will give you 756,000 cubic centimeters. Okay, and we know 756,000 cubic centimeters. Well, in this case, 1 cubic centimeter is equal to 1 milliliter. Well, 756,000 cubic centimeters must equal to 756,000 milliliters. And we can convert milliliters to liters by moving the decimal point 3 places to the left. Because 1 liter is 1,000 milliliters. So end up 756 liters. Part B, what is its mass in kilograms when it is full of water? Well, let's think of this. 1 liter of water has a mass of 1 kilogram. And 756 liters of water has a mass of 756 kilograms. Or, if you move the decimal point 3 places to the left, you'll get 0.756 metric tons. But I just want 756 as your answer in kilograms. Next, we'll talk about temperature, degrees Kelvin, and degrees Celsius. Degree Kelvin is the basic unit of temperature in the metric system, used only for scientific measurements. The freezing point of water is usually 273 degrees Kelvin. And then degrees Celsius is going to be the customary temperature measurements in the metric system. And this scale has 100 equal divisions, so the freezing point of water is 0 degrees Celsius, and its boiling point is 1,000 degrees Celsius. And then we got degrees Fahrenheit. That's used in the English system of measurement. And this scale has 180 equal divisions, so the freezing point of water is 32 degrees Fahrenheit, and its boiling point is 212 degrees Fahrenheit. And here we can compare temperatures in degrees Celsius and in degrees Fahrenheit. Now, 100 degrees Celsius is the same as 212 degrees Fahrenheit. That's the temperature where water boils. The normal body temperature in Fahrenheit is 98.6 degrees. That's equivalent to 37 degrees Celsius. On a hot day, 86 degrees Fahrenheit on a hot day would be 30 degrees Celsius. On a warm day, 77 degrees Fahrenheit would be equivalent to 25 degrees Celsius. 68 degrees Fahrenheit, that's the normal room temperature, is equivalent to 20 degrees Celsius. And on a cool day, 50 degrees Fahrenheit will be 10 degrees Celsius. And the freezing mark, where water freezes, is 32 degrees Fahrenheit. That's 0 degrees Celsius. Okay, so how can we convert from Celsius to Fahrenheit or from Fahrenheit to Celsius? Here we have these two formulas here. To convert temperatures, we use those formulas. From Fahrenheit to Celsius, we use this formula at the top. 5/9 times the quantity F minus 32. F is the number of degrees in Fahrenheit units. And if we want to convert from Celsius to Fahrenheit, we use this formula. 9/5 times the degrees Celsius plus 32. Now let's look at a couple of examples of just this. Let's say we want to convert 10 degrees Fahrenheit to Celsius. So 10 degrees Fahrenheit is equal to how many degrees Celsius? Okay, so in this case here we have to use this formula. C is equal to 5/9 times F minus 32. So in this case here we got 5/9. Now the degrees Fahrenheit is 10 degrees, so that's 10 minus 32. Now 10 minus 32 will give you negative 22, so we got 5/9 times negative 22. So here we're going to do 5 divided by 9 times negative 22. You're going to get negative 12.22 repeating. Now we're going to round this off to the nearest degree. So it'll be negative 12 degrees Celsius. Okay, that's how we convert from Fahrenheit to Celsius. Okay, now let's say I want to convert, let's say 15 degrees Celsius to degrees Fahrenheit. 15 degrees Celsius, and I want to convert that to degrees Fahrenheit. Okay, so now we have to use the second formula. Fahrenheit is going to be 9/5 times the degrees Celsius plus 32. So that means we're going to have 9/5 times the degrees Celsius, that's 15, so that's 9/5 times 15 plus 32. Okay, 9/5 of 15 is going to be this. I can divide 5 into 15, that's going to go 3 times. 3 times that 9 will be 27 plus 32. Add 32 and 27 together, you're going to get 59 degrees Fahrenheit. So 15 degrees Celsius is equivalent to 59 degrees Fahrenheit. Okay, so that's how you convert from Fahrenheit to Celsius. All right, and that will conclude this particular video on volume, mass, and temperature.